All right, so I'm looking at Pythagorean Theorem. Move that formula chart out of our way. And I like these questions, so I did want to film them. It wasn't part of our math lesson, but it actually was part of mine. So it says you got a right triangle formed by 3 squares. By the way, don't say rectangle now, does it? And I'm going to ask you some questions. Now, before we get carried away, that 7 millimeters means length. So that means this piece is 7 millimeters long. Okay, that's easy enough. 7. Got it. This is area. Do you see that millimeter squared right there? That's not length. That's area. You need to unarea it. Do the square root of that. And if I'm not mistaken, the square root of 576 was 24, but I hate to lie to you. Yep, I got all kinds of crazy stuff on my screen. The square root of, I don't remember, 576. Close the door. 24. Pretty good memory. Goes here. Aren't you looking for x? What formula in my class do we use if we're looking for x? Why yes. Why 1, why 2, why not? Because Lin-Reg solves for m and b. And I'm looking for x. So I'm going to do a squared plus b squared makes c squared. So you're going to put 24 squared plus 7 squared equals don't know squared. I want all of that in y1, and I want that in y2. Stop the video. Alrighty, so I went to my calculator. I got 24 squared plus 7 squared. I know that's hard to read. Let me pick that calculator up. And then x squared. I rolled my window really big. I count, it has to be seen. Whether I can see it pretty or easily, that's not important. But it has to be seen by the calculator. So I rolled 1,000. I did count by 100. By the way, that is scale factor, as in dilation scale factor. There's my graph. I've already pushed that button, so it's already calibrated. So you're going to go do second trace, 5, and then 3 enters. 1, 2, 3. And guess what? 25 is the answer. Now you're going, but I don't have a 25. I noticed, but I will put x equals 25. And you know, very few kids have troubles with this. Can't you just take this x out and write 25? Yep, you could. What about over here? How about 25 squared? So is 500 something plus 725? I would hope not. What about 500 plus 49? No. What's 25 squared? Well, if you know your 25s, it's 625. So is 500 minus 7 going to be a 600 something? Nope. Answer's D. Pretty easy. Question 2. I like this one a lot. Do you see that shaded part? That means it's filled in. If my class is listening, we could play with a paper plate and a penny and trace a penny on a paper plate, discuss area at great detail. We could even use the dime and see if that made it better. Yeah, no, I heard a lot of no's all of a sudden. So this is shaded, this is unshaded. Those aren't the same words, and they play a little different. And if you get down here, it even talks about length. That's totally different. They want to know which one of these things is true, so off you go reading. It says the area of the shaded, that's this piece, is equal to the sums of the two unshaded. Now, for me, I'm going to recognize this is A, that's B, that's C. You should know this is the largest. My kids are taught that's like small, medium, large. So you got small plus medium equals large. So they're saying the medium is the large plus the small. No, it's not. It's just, these two, sure, but not large plus small. Choice G says you could subtract the two and get the medium. I'm going to say maybe. I'm going to put in maybe here. H says side length equals shaded. Now, you know, if I want to look at side length, that's a ruler thing. So you're going to tell me a ruler plus a ruler makes shaded. If you were in my class, you watched the water video. You know, when they turned the pinwheel and the water dribbled out into the other squares. Because A plus B made C. It was a great water video. You'll find it on my other links. But they did water plus water made water. Not ruler plus ruler makes water. You can't add length with shaded. That's impossible. Kindergarten could teach you. You have to add like things. These are both wrong. Answer's maybe. Let's look at another one. I like question 1 too. Pretty quick. They're pretty sharp. Look at that one. So what is this piece on this triangle? 15. And for me, I'm like, it's too busy. I'm just going to draw my own. You know, if push comes to shove, do yourself. I need this number here, and I need this number here. Now I can tell you this one, x. Yeah, like as in solve for x. And you're going to need a square root of 289. I don't remember something. Square root 289. Close the door, children. 17. 17 goes here. So aren't you solving for x? Are you solving for x, you said? So wouldn't that be a squared plus b squared equals c squared? And wouldn't that be y1, y2, y naught? So then I'm going to have a squared plus b squared makes c squared. And wouldn't that be 15 squared plus I don't know makes 17? If you set this up correctly, you'll end up with x equals, I think, 8. And what's the square that has an 8? Wouldn't that be an 8 by 8 maybe? How about choice D? 8 by 8. One of the kids made a comment. It's the only one with an 8. Yeah, I know. That's a good comment. Let's look at a different packet. Alrighty, I pulled translation, reflection, rotation. We've already done dilation, but I'll shoot over here so you can see my dilation numbers. It's a multiplication thing, period. When? Always. So if you have x, y yield 2/3 x, 2/3 y, if you type in 2/3 in the calculator, you're going to get 0.67 if you're mode flow 2. That means you're going to make this thing smaller. And if you do x, y yield 3/2 x, 3/2 y, if you do 3/2, you'll get $1.50. That makes it bigger. So they look like that. They don't have add signs, no subtract signs. And less than 1 makes it smaller, more than 1 makes it bigger. And that's just pretty logic. So I'm going to scoot on over so you can look at these. So you've got the word transformation here. You know, that means changing a position, a shape, a size, a figure, and I'm not going to use that word to actually do anything. You're thinking this word is this word. They're very different. So if you're having to learn one, just learn that one, because this word means all of them. Next, so this one's slide, flip, turn. You probably know those from elementary, or you better. So let's shimmy on down here to translations. See that T right there? I made it a lowercase t. Why? Because it looks like an add sign. And if you look right there, that L, that's a subtract sign. And that's it. Because look at this. I'm going to go to the algebra part. So when you have add and subtract, it's translation. Okay, the end. Who is the x? Yeah, I asked that question today and got some really good answers. Why don't we go with the x-axis? That's even a better answer. And how about the y-axis? That's a good one. What does the x-axis do? Which way can you go on the x-axis? You might go right or left, but you don't go up or down on an x. And look at the y-axis. You can go up or down, but you're not going to go left or right. So be careful about left, right, up, and down. You have to know where you're at and where you're going. In order to go up in the car, I don't know how you're going to do that except an elevator. Hot air balloon might go up though. Car tends to go left and right. Alrighty, so let's look at some examples. I'm going to shimmy, shimmy. Keep turning. Like this one here talks about, see that right there? What does that mean? So on the x-axis go left 4. Left 4. On the y-axis go down 3. Down 3. And the y is pretty simple. If your grades go down, like why do your grades go down? Why do your grades go up? Y is an easy one to remember. X, how about the other one? So I needed to go left 4, down 3. So, you know, the grade sheet, we'll use our brain on this one. You're going to put your little finger here and you're going to go 4 little bunny hops. 1, 2, 3, 4. And then you're going to go down 3. 1, 2, 3. And that's where you're going to stop. So does A look like it's sitting like there? A didn't move. Look at B. Maybe. It did go left and it did go down. What about C? It forgot to go left. What about D? It forgot to go down. I think you better pick the maybe. We ran out of choices. Look at 3. You get this crazy shape, and that's the word, crazy. And it's wanting you to flip it across the y-axis. Now, I'm kind of crazy about this kind of stuff. I kind of like you to lay your pencil on the y-axis. Why? Because I don't know. I'm just that way. And you put your little finger over here where this crazy shape is, and you jump over your pencil. It's pretty cool. And that is all the strategy you need. Now move your crazy pencil. Now look, the little V part is up, and the little point is down. Go find something that matches that. Well, there's no V at the top. There's no V at the top. Yep. Nope. See? And I'll have kids miss this. Why? They didn't bother to put their pencil there. They didn't bother to jump over their pencil. They didn't take the time to draw some type of characteristics. It's got a little V thingy right here, and it's got a little pointy thing. You got to have some type of symbol to clarification of top, bottom, left, right. I don't know. Let's do another one. Yeah, that one was the same thing. Let's pick something different. What about that one? Question 7's a good one. What is this x minus 4, y plus 3? Yep, what did we say about x? Who is x? X is the flat one. Which way can you go on the flat road? Right or left? So it says left 4, so you're going to go left 4. Y is the up and down. And your up and down went, let's see, up 3. And so you just match them. For me, I like to read myself before I get carried away, because when you read all of that, yeah, I done forgot the question. This one here, I thought that one was harder. You had to take the shape and actually redraw it. And then you had to know your quadrants, 1, 2, 3, 4. And if you're trying to remember the quadrants, doesn't quadrant sound like C for cat? Well, there's a C. 1, 2, 3, 4. And who's kidding? How do you draw a Q? About the same way. 1, 2, 3, 4. That's 1, that's 2, that's 3. That funny looking one must be 4. Only got 4 parts. By the way, to read Roman numerals, that's a 5. Something on the back of it is subtract. Something on the front of it is an add. A little trivia. And if you look at this right here, x minus 5, that's going to be x-axis go left 5 because x's go left or right. And that's going to be y-axis go down 4 because y can either go up and down, and well, that's a down. And then if you, I moved all those points, redrew it. And if you notice, each point is in a quadrant. Choice A. I'm looking for something different. Those are about the same. This one was kind of cool. You got to think about it. I kind of like those. So you've got this shape thing going on. And I just highlighted M because there's way too much stuff. I get confused with way too much stuff. So I picked one. I picked the top one. Look at -8. And then here's -6. I'm looking at the x-axis in particular. And so I'm going to go to the x-axis. Here's 8, right? -8. How do you get to -6? I think you go right 2. And that's what I wrote over here. What if you go on the y-axis and go to 6? How do you get to 0? We need to go down 6? Yep, my camera's slow. So I got right 2, down 6, and then you're going to match. And all these are translations because you got adding and subtracting. Dude, there's my plus sign and there's my subtract. Love translations. Like the answer's on your paper. It is on your paper. Alrighty, so here's my rotation pattern, and you'd have to just memorize it. That's probably the best thing I can tell you to do, or I guess get it wrong. Alright, here we go. Rotation. It's flip, don't flip, 1, 2, 1. Yeah, I know, it's a killer. If you can keep up with the phone number and you can sing all those crazy songs, I think you can keep up with that if you want to. And I actually put this as a first, and I actually made this an L, because it was actually 1, 2, 1. So, flip, don't flip, 1, 2, 1. And go back to this one and make it a first, and go back to this one and make it an L. So you're going to have x, y yield, and they all have that. So you're going to take x, y, and you're going to do the first thing. You're going to flip it. So you would just have y, x. Then you're going to write x, y. Then you're going to write y, x. And then I'm going to come back to this side. I'm going to put 1 negative first. I'm going to put 2 negatives. And I'm going to put 1 negative last. Pretty smart, right? And then let's start counting by right angles. 1 right angle, 2 right angles, 3 right angles. That's counterclock, by the way. Now let's count backwards, or actually count forwards and right backwards. 90, 180, 270. There's a multiplication thing that looks like that for 9s. Yep, there's my little pattern. So let's go answer some questions. I think question 21 was something like that. I actually had the kids write it off on their paper from memory. It's not too bad. Flip, don't flip, 1, 2, 1. And then counting by 90s. So that's kind of all you had to memorize. So I wrote, so you flipped them, you don't, you flipped them. You got 1 negative, both negative, last negative. And then 90, 180, 270, and then 90, 180, 270, counterclock, clock. That's 90 clock, and there's 90 clock. So this is your answer, D. When would you use that? I don't know, when you're turning something, apparently. Look at question, I don't know, I think it's 5 I skipped. I thought this one was harder because you had to name the ordered pair and all that fun stuff. So I took this shape and named that point. I grabbed something random. It's -1, -1. I wrote my pattern. If you notice, it said 180 clock. That's here. It says -x, -y. -1 times negative, positive. -1 times negative, positive. And then I went and found 1, comma 1 pair, and it was answer A. Alright, my video is about to stop. I'm going to move on to the next lesson. Catch you at the next video.